Okay, there we go. Hello, my algebra students. It's saddening me a little bit that this is how we're going to have to do things, at least for the time being. I'm hoping this isn't the way we have to do things for the rest of the school year, but on the good side of things, I at least have gotten myself prepared and know what to do in this situation as far as teaching you this way, and you all, for the most part, at least should have some familiarity with it as well. So the intention is going to be just like what we've been doing, except obviously there'll be no substitute looking up the site on YouTube and hitting play. Instead, it'll be up to you to do that. Now the hard part is you will not be able to access YouTube with your iPads, right? So what you're going to have to do is use a different device, a phone, a computer at home, a laptop, something else besides the iPad to watch this video. And then we'll use your iPads though for live communication and utilizing the school resources. I hope all of you are well and stay well, and if you get ill, that it passes quickly. The good news is for you all at your age, this virus for whatever reason is not significantly impacting your demographic. I'm on the edge of the ones where it starts to get worrisome, but I'm still in my low 50s, so I'm not too terribly worried. If I get sick, I may feel not great for a while, but anyway, I'll worry about that if and when it comes. So far, so good. Okay, so what I wanted to get into first is finishing off exponents, which is where we left off just before spring break. There's a couple of things I want us to go over that aren't too terribly complicated. I want to get through that at the beginning or at the end of this week, just as an introduction, because then I want to move forward next week in step with Mrs. Delacruz with her algebra class over at Fleece. So we get through these two lessons this week with a couple of homework sections and we should be fine. Okay? So the first one is lesson 6.5. Let me look and tell you what page that's on. It's page 326, lesson 6.5. It is solving exponential equations. For those of you that, I'm confident there'll be some of you that will not be able to access the Big Ideas book on your iPad, that's fine. I'm going to put out there every copy of everything that we're covering. I'll put up the instruction pages as a snip, as well as the exercises on Schoology. So if you can't access it via Big Ideas, then access it via Schoology. I will create the assignment in Big Ideas like I've been doing. And again, if you can't do it that way, I also will create the assignment in Schoology, submit it one way or the other. Preferably, I would like you to submit it via Big Ideas. If you can't get that to work, put it in through Schoology. Please don't do both. That's just extra work that you don't need to do, okay? And I'll be keeping tabs as we figure this out. Honestly, we're going to figure this out on the fly, how we're going to go about doing this school year online until we hopefully get back to where we see each other face to face. Okay? So that being said, it's page 326, 6.5 is our lesson. Okay? Make sure I have this and blow it up as much as I can. I'm filming this by myself, so I'm trying to make sure that you're seeing what I need you to see. All right, so it says core concept, property of equality for exponential equations. Two powers with the same positive base, designated by the letter B, are equal if and only if their exponents are equal. And they give a couple of examples. If 2 to the x equals 2 to the 5, then x equals 5. If x equals 5, then 2 to the x equals 2 to the 5th. This should not be challenging. It's going to be better if I show you examples. All right, so this first one, letter A, solve each equation. So this first equation says 3x plus 1 equals 3 to the 5th. We have like bases. What is the base? It's 3, right? We have a base of 3 and a base of 3. 3 to the x plus 1 equals 3 to the 5th. So the very simple thing you can do algebraically is get rid of the bases and just set the exponents equal to each other. X plus 1 equals 5. And then just solve for that. Subtract 1, x equals 4. Okay? Letter B says 6 equals 6 to the 2x minus 3. They're throwing a slightly tricky one up here because the first base, 6, has no exponent. You all should know by now, we've talked about it, if there is no exponent written for a base, the unwritten exponent is the number 1. So this is 6 to the 1 equals 6 to the 2x minus 3. So set those things equal to each other. 1 equals 2x minus 3. Add 3 to both sides. I have 2x equals 4. And then just divide by 2, of course, and x equals 2. And they've worked it out down below as well, so you can see it for yourself if you can't see what I'm writing. And lastly, letter C says 10 to the 3x equals 10 to the 2x plus 3. Again, the bases are equal, base 10, base 10, so just set the two exponents to each other. 3x equals 2x plus 3. Subtract 2x from both sides, I have x equals 3. Okay, and you can always substitute this back in for the variables up here in the bases to make sure it's right. If I substitute this in, the first side I have 10 to the 3 times 3, which is 10 to the 9th. 10 to the 2 times 3, which is 6, plus 3, which is 9. So 10 to the 9th equals 10 to the 9th. We know our solution is correct. Get the eraser. All right, I'm going to roll up. What I would like you to do at this point is pause the video on monitoring progress. You've got 1, 2, and 3. I want you to pause the video now, work those out on your own. Okay? This is considered something like bell work. I want you to work them out on your own. For right now, we're not going to submit these in the future. For other ones, we will, I believe. But for right now, this is for you just to work it out to make sure you've got it. So go ahead, pause now and work in these, and then I'll work them out when you come back. All right, so we're back. Number 1 says 2 to the 2x equals 2 to the 6th. So again, same base. The base is 2. So just set those exponents equal to each other. 2x equals 6. You can see how simple this algebra now is. Okay? Divide by 2. X equals 3. Okay? That's for number 1. Number 2, 5 to the 2x equals 5 to the x plus 1. Like bases, the base is 5. Set them both equal to each other. 2x equals x plus 1. Subtract x from both sides. I have x equals 1. Very, very easy, right? Great. And number 3, 7 to the 3x plus 5 equals 7 to the x plus 1. Again, like bases, set them equal to each other. Just the exponents. 3x plus 5 equals x plus 1. And do your algebra. We'll subtract x from both sides. 2x plus 5 equals 1. Now we subtract 5 from both sides. 2x equals negative 4. Warning, warning. Divide by 2. X equals negative 2. Okay, great. Sliding over. Solving exponential equations with unlike bases. All right. Understand when these pop up, the bases start out unlike, but what you have to look at is, can I set them to where the bases are the same? So they give you these 3 examples under example 2. This is on page 327. The first one says 5 to the x equals 125. 5 to the x equals 125. So what you have to ask yourself, you've got a base of 5. Can I rewrite 125 as a base of 5? For many of you, I think you'll see this, that 125 can be rewritten as 5 to the 3rd. We've done this with our exponents. 5 times 5 is 25. times 5 is 125. So 125 can be rewritten as 5 to the third. This is where you knowing and being able to recognize common squares, cubes, etc. will help you solve these things, okay? And you'll have to use your calculator sometimes to help figure it out as well. So when you rewrite it this way, we have 5 to the x equals 5 to the third. We now have like bases. Very easily we can see that x equals 3. And you're done. The next one says 4 to the x equals 2 to the x minus 3. Take your smallest base, which is 2. Can I rewrite 4 in base 2? Most of you should know that by now, that if 4 is 2 squared, right? So you have 2 squared to the x. That's how you rewrite that. 4 to the x becomes 2 squared to the x. Remember, we learned this in our exponents. When you have one exponent raised to another exponent, you multiply those exponents together. You've got to remember your rules. So this becomes 2 to the 2x equals 2 to the x minus 3. Now we have like bases, a 2 and a 2. So I can just set the exponents equal to each other. Okay? So now I have 2 to the x, or 2x equals x minus 3. Do my simple algebra, x equals negative 3. Okay? Letter C. 9 to the x plus 2 equals 27 to the x. A slight more bit complication because I've got two different bases I'm looking at right now, 9 and 27. You cannot simplify 27 as 9 times something, right? Because 9 times 9 is 81. But both of these have a smaller base that they both can be raised to. What is that base? Some of you are like, I don't know what you're talking about. I understand. Stick with me. These are examples. Look through them on your own. You'll see it. 9, you should all recognize, is the same as 3 squared. So I can rewrite this as 3 squared to the x plus 2. Hopefully most of you, well, preferably all of you, but hopefully most of you recognize 27 is 3 cubed. 3 times 3 is 9, times 3 is 27. So you can rewrite this one as 3 cubed to the x power. So now I multiply the two exponent items together. So this one is 2 times x plus 2. It becomes 2x plus 4. I'm getting rid of the bases because they're the same. And this becomes 3 times x, which is 3x. So now I have my simple algebra. I hope you can see, if you can work this down, the algebra itself is very easy. You just got to remember what your common bases and multipliers are. Okay? So I have 2x plus 4 equals 3x. I subtract 2x from both sides. I get x equals 4. The algebra itself is simple. Getting there with your rules of exponents is what's going to trip most of you up that struggle with this. Okay? Practice will make perfect, I promise you. All right. So I think we're getting to that point now. Let me see. Oh, no, not yet. So they wanted to make it just a little bit more complex when solving exponential equations when 0 is less than b is less than 1. Okay, when the base is a fraction is what they're saying. When your base is a fraction. So your first one, letter A, says 1/2 to the x equals 4. Okay, you're like, gosh, that looks strange. Remember, we can rewrite 1/2 as 2 to the negative 1. When we had negative exponents, you just flipped it, and 2 to the negative 1 became 1/2. So we're reversing that. We're bringing up the 2 to the numerator, and it's making it negative 1 raised to the x equals 4. We want like bases of 2 equals 2 squared. Now I multiply these together. Negative 1 times x, so it's 2 to the negative x equals 2 squared. I have like bases, I get rid of the bases. I have negative x equals 2, divide by negative 1, x equals negative 2. Okay, that's the first example. Second one, 4 to the x plus 1 equals 1/64. Okay, 64 is 4 cubed. 4 times 4 is 16, times 4 is 64. So I can rewrite this, the 1/64th, as 4 to the negative 3. Okay, and that equals 4 to the x plus 1. So now I have like bases. I can get rid of the bases and do the algebra. X plus 1 equals negative 3. Subtract 1. X equals negative 4. Okay, so that's when you have fractions. You just bring them up and reduce them to negative exponents, okay, as needed. All right, so I'm sure we've got some examples now at the bottom for you all to pause and work on. We sure do. 4, 5, 6, and 7 on page 327. Go ahead and pause here and take a few minutes, solve these, start it back up again when you're ready, and I'll work through them with you. Okay, so the first one, number 4. 4 to the x equals 256. I'm at that point now where I need to bring out my calculator to make sure of what I'm about to tell you. Yep. Okay. So we have our smallest base present is 4. So is there a root of 256 where I can get the base of 4? And there is. 256 is 4 to the 4th. I didn't know that, I suspected it, and so what I did with my calculator is I just went 4 y to the x to the 4th, because I knew from before 4 to the 3rd is 64. I'm like, I think 4 to the 4th is 256, so just one more, 4 y to the x to the 4th, or 4 times 4 times 4 times 4. Okay, so 4 to the x equals 4 to the 4th. Then get rid of the bases, x equals 4. Okay? Number 5, I have the base of 9 and the base of 3. Most all of you, if not all of you, should know by now, 9 is 3 squared. So 3 squared to the 2x equals 3 to the x, 3 to the x minus 6. Multiply these together. It's 3 to the 6x equals 3 to the x minus 6. Set those two equal to each other. 6x equals x minus 6. Subtract x. 5x equals negative 6. Divide by 5. And this is ugly. X equals negative 6/5. That seems like ignore what I just did. I knew that wasn't coming out right. Because 2 times 2x is not 6x, it's actually 4x. Isn't that nice? If I was smart, I'd rewind this and start all over again so you wouldn't know that I made a mistake, but you know by now I do. So let's try it again. I have 3 to the 4x, sorry about that, equals 3 to the x minus 6. So now set them equal to each other. 4x equals 3x minus 6, subtract 3x, and I have x equals negative 6. See if I like that. It does. That makes much more sense. My apologies. Restart if you need to. All right. Number 6. 4 to the 3x equals 8 to the x plus 1. You have to do that extra step here because the lowest base present here is 4, but 4 times 4 goes to 16, higher than this. What I need you to recognize is these both have a common base of 2. I can rewrite 4 as 2 squared raised to the 3x equals 8. I can rewrite as 2 cubed raised to the x plus 1. So I multiply these together. 2 times 3x gives me 6x equals 3x plus 3. 3 times x plus 1 is 3x plus 3. Subtract 3x. 3x equals 3. Divide by 3. X equals 1. Okay. Lastly, number 7, they threw in a fraction 1/3 to the x minus 1. What you need to do is flip that back up and make it a negative exponent. So it's 3 to the negative 1 to the x minus 1 equals 27. Remember, we have to have like bases. The like base here is 3. 27 is the same as 3 cubed. Okay? Multiply these together. I have negative x plus 1 equals 3. I'm going to add x to both sides. I'll have 1 equals 3 plus x. Subtract 3. And I get x equals negative 2. Let me see if I like that. Yes, I do. Okay, so the answer to 7 is negative 2. If I'm going at a pace you can't follow, or you want to see it done in a slightly different fashion, remember you can click on these icons in your Big Ideas book, and they will play these out for you so you can see them written out again. Please do so if you need to. Okay? Great. Let's see, it might be just about it, because this is a pretty short little chapter. Let me just see one other thing. Solving exponential equations by graphing. You know, we're not going to do that right now. We're going to skip past that. So, that covers that chapter. What I want you to do for homework. Let me see before I state it. Go to the other page. Ah, I like that. That's nice. All right. Just 1 second. Okay, so here's what I want you to do. I'm going to have you do one word problem, of course, because that's just the kind of guy I am. All right, so your homework is page 329, problems 3 through 17 odds. 3 through 17 odds. Then I want you to go to page 330 and do 37, 39, and one word problem, 42. Okay? You'll find all this on Schoology as well. So 3 through 17 odds, then 37, 39, and 42. When we meet together next week online live, there'll be your opportunity to ask some questions about the homework and things you don't understand, okay? Thank you for your time. I appreciate you all. I'm missing you, but dig in. Let's get through this together. This will be a lifelong experience you'll never forget, for better or for worse, okay? See you next time.